Hess's law is a very strong mode of calculations for enthalpy change of reaction. It simply states that the heat of reaction is independent of number of steps involved, as long as your products and reactants are exactly the same. Now it makes it possible to calculate few items, eventually delta H formation for a compound from combustion information, delta H of a reaction from formation information, and finally delta H lattice in Bowen-Haber cycles. But before we get there, let's just look at simple application of Hess's. For example, this question is, what is delta H of this reaction? And then we have related steps, and all I have to do is manipulate with equations in order to get the desired equation. The reactant N2H4, I see it in my first equation as is, so I'm just going to copy it down, and for sake of simplicity I'm going to ignore states of matter for this reaction. So first reaction, I'm not going to change anything, and what happens is delta H is as is, negative 37 kilojoules or kilojoules per mole. The second reaction, I see also ammonia on the product side, and that's what I want, so I'm not going to play with that reaction. Also, I keep it as is, giving me 2 ammonia, and it's negative 46 kilojoules. But the last equation, I see that I need to get rid of this CH4O in my first equation because it's not part of my overall reaction. So what I'm going to do is going to reverse the last equation in order to get rid of this CH4O. So I'm going to reverse that reaction, meaning I go from CH2O plus 2 hydrogen to CH4O. If you reverse a reaction, you're going to reverse the enthalpy sign. So it's positive 65. Now let's just add it and see if we get the overall reaction. CH4Os get cancelled. What's on the left and right, you can cancel them out. CH2Os go away. Nitrogen with nitrogen will cancel out. You have 3 hydrogen here and 3 hydrogen here. That goes away. Your final equation is left with N2H4 plus 1 hydrogen, giving you 2 ammonia. Exactly what you want. The states of matter are also exactly the same. They are all gases except N2H4. Now we're simply going to add these numbers out, and your final answer is minus 18 kilojoules or kilojoule per mole. So that's application of Hess's law. If you reverse a reaction, change the sign. If you multiply a reaction, multiply delta H as well. Let's look at another example. Now sometimes you have to spend a little bit of time in order to use the steps well. This question is, what is delta H of this reaction using the following steps? Now I see C2H2 ethyne is on the other side of my reaction, so I'm going to reverse this reaction. So the first reaction, I'm going to write it as C2H6 breaking into C2H2 plus 2 hydrogen. I'm going to change the sign from negative to positive. Now what I'm going to do is actually go after my third equation now. And I see that I need to get rid of C2H6 because I don't have it in overall reaction. And I also want CO2 on my reactant, so I'm going to reverse the third equation. So I'll bring it down here and I do the reverse. So I have 2 carbon dioxide plus 3 H2O giving me C2H6 plus 7 half O2. I change the sign because I reversed the reaction. 283. Now if you stop here, the C2H6 cancel each other out. So that was my intention. Now what about the second equation? What do I need it for? I see in my overall reaction I only have 1 molecule of steam, H2O. So somehow I need to reduce this. So I use the second equation here, and I'm going to flip it, and I'm also going to multiply it by 2. So I'm going to write it as 2 hydrogen gas. 2 times half is 1, so 1 oxygen, giving me 2 molecules of H2O. Not only I reversed it, which was negative 71.2, but I also multiplied the equation by 2, so I multiplied this by 2. Now let's see if we get overall reaction. Now at this stage C2H6 were cancelled, that's good. 2H2O will cancel 2 of the 3, so I only have 1 H2O left. Then let's see. 2H2 and 2H2, they cancel each other out. Now oxygen, I have 1 oxygen here and I have 7/2 oxygen here. So this one cancels one of the oxygens here, and I will have 5/2 O2, which is exactly what I want. Let's bring it down. On the left hand side I have 2 CO2 plus 1 molecule of H2O still left, yielding C2H2 plus 5/2 or 2.5 oxygen gas. Now we are just simply going to add all these numbers, and what I calculated was 46.1 kilojoules per mole. So that's the answer for this. Now let's look at another example of Hess's law. This one is rather easy to inspect and look at. What is delta H reaction for this? I see that PCl5 is on the reactant side, which I'm happy. PCl3 is on the product side, which I'm happy. So I'm going to keep these two as is. I'm simply going to add them up and see what I get at this stage. So P4 and P4 solid, they cancel each other out. 6Cl2 versus 10 on the other side, this 6 goes away and I only have 4. I bring down, I have 4 PCl5 gas, giving me 4 PCl3 gas plus 4 Cl2. Now if I add these two numbers, I will get 999 kilojoules. Now if you look at this reaction compared to what I want is, I want 1/4 of that. I'm going to divide everything by 4. The coefficient as well as delta H. Final answer, I get PCl5 giving me PCl3, Cl2, and when you take 9 divided by 4, you get 249.8 kilojoules. So that's Hess's. Finally, I want to do one other example. Sometimes you have to also apply the definition that you know. Calculate delta H formation for carbon monoxide using the following. So you have to go back to what you know about formation. Formation is when you form 1 mole of a compound from the elements in their natural or standard state. Carbon is found as solid monatomic. Oxygen is a diatomic gas. I only need half as much. So what is delta H of this? Using the following equation. So I see carbon and carbon on the left hand side, so I like my first equation as is. So let me just write it. Carbon plus oxygen giving me CO2. I didn't change anything. I keep the sign. I see the second reaction that CO is on the product side. So I'm going to reverse that reaction. 2CO2 giving me 2CO plus O2. And I'll change the sign, 588. I'm going to divide it by 2 because I only want 1 carbon monoxide. So I will divide this by 2, divide this by 2, 1/2, divide this by 2. Now let's just see what we have at this stage. I have, let's see if we can cancel anything also as well. CO2 and CO2 cancel at this stage. You have left with carbon. 1/2 oxygen on the product side versus 1 oxygen here. This goes away and this will end up to be 1/2. So carbon solid plus 1/2 oxygen gas gives me 1 molecule of CO. Now I'm just going to add these numbers and see what I get, and in a calculator I get -99 kilojoule per mole.